Let's remember once again what are the sizes, what are the advantages and disadvantages of different sizes of unit load. So the size, when we talk about size, we consider the volume or the weight of the unit load. And this has a major effect on the specification and operation of the material handling. So if the size is smaller, you may use a different type of material handling, and if it is larger, then you have to use a different type. When we consider larger unit loads, so what are the advantages of using larger unit loads? The most important advantage is, as we made an example in the previous lecture, you need to make fewer moves, okay, less number of moves. And again, large unit loads facilitates the efficient start and finish of the processing, especially for the receiving, shipping, these type of operations, since you are processing all these parts at one time, so you finish the processing easily and you don't need to initiate every time. On the other hand, what are the disadvantages of these unit loads? Larger unit loads are bigger. You need to have bigger and heavier equipment to be able to hold large number of parts. You need wider aisles for these bigger equipment, so you need more space basically. And your floor load capacity should be higher so that it will be able to carry these heavier equipment. And you will have higher VIPs because one unit load, for example, if you have larger unit loads, one unit load may mean hundreds of items, and they will all be transported and stored at once, which means that your VIP levels will be higher. On the other hand, if we look at the advantage of small unit loads, so the disadvantage of larger unit loads in most cases are the advantage of smaller unit loads. So you will have lower VIP, you will have simpler material handling equipment, and since it's simple, it's smaller, you will need lower initial investment. You won't need to buy expensive equipment, okay? And since you will have lower VIP and you are moving smaller quantities of parts at a time, this supports the just-in-time production philosophy and the continuous flow within your facility. As we showed, usually when you reduce the number of smaller, the size of the loads, if it's smaller, then the completion time is usually shorter. But of course, in the previous example, we have shown that in some cases, it may also lead to an increase. But we are talking generally now. And with small unit loads, you have higher flexibility. On the other hand, when you have smaller unit loads, the basic disadvantage is it increases the transportation requirement. So how can we decide on the optimal unit load? In order to decide on the optimal unit load, you need to consider different objectives at the same time. The optimal unit load is the quantity where the idle time, work in process inventories, and the transportation costs are minimized. Okay, so if you can find such a solution that minimizes all of them at once, that is the optimal unit load for your system. Then how can we design this unit load? For example, assume that we decided on the size of the unit load. Then what are the methods of unitizing this unit load? The most common methods include using containers, different types of containers, whether plastic or metal, and etc. Using different types of platforms. For example, you are all familiar with pallets. For example, this is an example, or skids like this you can use to carry and store items on these skids. You can use sheets. It can be cardboards, plywoods, or polyethylene slip sheets. Then in order to store the items, for example, using racks, using strapping and wrapping, So the wrapping can be either a stretch wrapping or shrink wrapping. For example, in the shrink wrapping case, you use a material so that when you apply some heat on it, then it shrinks and covers all the material tightly. We said that material handling is related with moving the items, storing the items, controlling the items. So we use unit loads, unitizing equipments to decide on the amount and the quantity of items to be moved and stored at once. So moving the items is an important aspect, and these unit loads facilitate these moving of the items at the same time, not only for storage but also for moving the items. Then what are the basic methods of moving the unit load? Basically, we can talk about 4 methods. The first one, a common one that you are all familiar with, is the lifting the mass, the unit load, under the mass. Okay, lifting it under. For example, this one is an example. You have, let's say, a pallet, and with a forklift, you lift it and move it and transport it. The second method is inserting the lifting element into the body of the unit load. In some cases, the items are soft and they are not damaged. So you use, for example, forklift and insert this forklift into the body and carry and transport it in this way, lift and transport. The third method is squeezing the load between 2 lifting surfaces, so that this is the item. So on 2 opposite sides, you just squeeze the item. For example, a material handling robot has a gripper, so that using this gripper, it squeezes the parts on this gripper and moves, carries and loads the machines, for example. And the fourth method is suspending the loads. For example, if you have a jeep crane, hoist, or a bridge crane, you can suspend the item using such chains or cables, and then using a hook, you can lift them up and transport. Okay, these are the 4 methods of moving the unit load, common methods. Typically, these unit loads are covered in containers and carried and stored as containers lying on these pallets and carried in trailers. These are typical movement and storage of the items. When you are designing this material handling system and unit loads, you need to consider the dimensional relations between the containers, pallets, trailers, storage racks, and spaces. So usually there are some standard sizes for these. The pallet sizes, usually they are in standard. There are different standards. And in order to design your unit load and in order to design your containers, for example, you need to design your containers such that a number of containers can fit perfectly on the pallets. Similarly, these pallets should be able to fit on the storage racks perfectly. So the dimensions and the sizes of these storage racks and spaces should be suitable for the containers and pallets and etc. So the dimensional relations are important. Containers are one of the important unitizing equipment and important in material handling design. They are basically returnable and reusable types of unitizing equipment. If you are using, for example, cartons are not suitable for returning or reusing, but these containers can be used again and again. Another advantage of the containers is they are stackable, so that you can put one container on top of another, so that on one pallet you can stack these containers on top of others and carry a number of containers at the same time. Okay? So lids or tabs provide this feature, okay, on containers. And another thing is they are nestable. If the containers are empty, their shapes are designed in such a way that So if you want to carry empty containers from one space to another, you can nest them, a number of them, into each other, and you can carry them easily without requiring too much volume. As you can see, these are some examples of stackable and nestable containers. You see a number of containers stacked on one top of each other, and they are also placed on a pallet. Okay, so these are stackable containers, and you see there also, when they are empty, they are nested. So this is one container, another container is nested into that, and another container is nested into that. So three containers are nested into each other, and you see the sizes of the containers are in such a way that, so 1, 2, 3, and 4 containers can fit on a single pallet. And you see the dimensions of the pallets can be different as well. There may be different standards, and depending on the size of the pallets, the sizes of the containers should be arranged. So there may be different sizes and dimensions for these containers depending on the dimensions of the parts that you are producing, and your decision on the unit load, the size of the unit load. You should decide on the size of the container, and when you are deciding on the size of the container, you should consider the equipment, the pallets or skids that will carry these containers. The dimensions of those pallets and skids should also be considered. Pallets are also very common in industry for containing the unit load. So either the parts themselves directly can be placed on the pallets, or first the parts can be placed on a container, whether a cardboard or plastic or different type of container. Then these parts or these containers can be placed on the pallets. As I said, these pallets come in a variety of designs, different shapes and dimensions. They can be plastic, or most common they are in wood. They are made up of wood. There are different pallet sizes. So in centimeters, different common pallet sizes are 80 by 100 or 100 by 120, and etc. So these are some common sizes, and it's very important to decide on these sizes, because, for example, when you select this size, when you are using this size, and if you want to store this on a rack in your storage, and then your pallet should be fit into your rack. And on the other hand, when you want to send these to your customers, okay, then the truck, the carrier of the truck, the size of that carrier should also be fit well with the size of the pallets. Okay, so the dimensions of these containers, pallets, are very important. So these are different types and designs of wooden pallets. As you can see, all of them has a different design. For example, in this one, the forklift enter into this side and lift it up and carry. And you see, when you compare these two designs, in this one at the bottom you don't have these wooden parts, but here at the bottom you also have these wooden parts, and the forklift enters through this side. And we can say that when we compare these two alternatives, we are using less wood to construct this, but the strength of this one is more than this one. So there's another alternative here, for example, but if you want to you see in the top of this pallet does not have a continuous surface, so there are gaps. It means that the items that you are putting on these pallets should be larger so that they will not fall into these gaps. But on the other hand, we are using less amount of wood here, so that the pallet cost will be less. These are two common types of pallet designs. This one is the stringer design, and this one is the block design. And basic difference here is you see in this design there are such stringers, runners, so they are continuous from one side to the other side. But in the block design, you see there are no such continuous runners. So there are small blocks and all these pallets are installed on these blocks. Okay, here we have continuous runners, but in this version we don't have. So these are common types of designs, different designs. They have their own advantage and disadvantage. There are different types of pallets with respect to use of type of material. So the most common alternative is the wood one, or it can be a pressed wood fiber, corrugated fiberboard, plastic, or metal. And each one of these materials have their own advantage or disadvantage. And while deciding on which one to use, you should consider these advantages and disadvantages. Basically, you can talk about the weight of the pallet because you want the pallet to be lightweight as much as possible because you need to move it, you need to carry it, and if you are carrying a heavier weight, it will be costly and you will require a larger material handling equipment if the pallet is not too light. Depending on the durability, again another criteria to evaluate alternatives is to look at their durability, their repairability. If it's broken or something happened, then can you repair it? Its environmental impact, whether you are using recyclable material or not, okay, and again, you need to consider what type of applications you are going to make with these pallets so that depending on those applications, specific type of pallets can be more suitable. So for example, when you compare a wooden pallet, let's say with a pressed wood fiber, you see this wooden pallet is more heavier than the pressed wood fiber. Depending on durability, you see wood has a medium durability, but on the other hand, metal or plastic has a high durability. When you consider repairability, you see wood is highly repairable, but if you use pressed wood fiber or corrugated fiber board, they have low repairability. With respect to environmental impact, the wood is biodegradable or recyclable, and also the metal, for example, it's recyclable. Okay, so you need to consider which alternative has less environmental impact. And you can consider the typical applications. This wood, for example, is very common. You can see it in many places. So in general use, including this groceries, automotive, durable goods, and hardware, we all can see these wooden type of pallets. An important design related to the pallets, use of pallets and containers, is the pallet loading problem. So the relationship between the container and the pallet is referred as the pallet loading problem. So how you are going to stack these containers on the pallets and which type of pallets you are going to use. And the objectives of pallet loading are you want to utilize the space as much as possible. So you want to, what are we talking about? The space of the pallet, so that the containers should fit on the pallets so that the empty space on the pallet should be minimized. On the other hand, the stability of the load is very important because there are a lot of accidents that you can see even in YouTube if you search. If you do not stack the items on the pallet in a stable way, the loads can fall down and lead to damage and cost. Okay? So the stability is a factor affected by how you load your pallet, and also the cost. We want to minimize the cost by using this pallet loading. So by an efficient loading, you may reduce the number of transfers, you may reduce the number of pallets required. So we want to minimize the cost as well. If a company sends items to other countries, it means that if it's a member of the international supply chain, then some other considerations should be followed. So different countries may have different pallet standards, and if the sending country uses a larger pallet, but if the receiving country uses a smaller pallet size, then the racks, the material handling equipment, and etc. in the receiving country will lead to problems. That's why you need to decide on this earlier, and usually we can say that the most cost-effective pallet choice for the overall supply chain is to use the pallet size of the receiving country. Okay, so if you are sending to another country, you should learn about the pallet standards of the receiving country and use those standards. These are some standards, different alternatives of loading the pallets, stacking the containers on the pallets. You see in this loading, the space is fully utilized. These are the containers, individual containers. But in this type of loading, for example, you can consider the stability of the load because they are independent of each other, which means that this column over here can fall down easily, and these containers, they are not connected to each other, so they can fall down. And in order to increase the stability of such loads, usually stretch films or shrinkable films are used in order to increase the stability of the load. On this one, you see a different type of loading is used, and these are rectangular shaped containers. So at one level, you place the containers on this orientation, in the second one on this orientation, on the 90-degree turned orientation. Here you use this orientation, and finally you use this orientation so that you increase the stability of the load. Again, this is another example of loading. You see at the midpoint here, there is a gap. It's not possible to fully utilize the whole space, and in order to increase the stability of the load, the pallet, such a loading is used. Again, you can observe different types of loading depending on different dimensions of the containers and the pallets. And all of these loading, which one should you select? Which one is the perfect way? Again, as I said, you need to consider the space utilization, the stability, and the cost. And depending on that, you should select which alternative is most preferable for you. And also, you should, of course, consider the sizes of the loads, the containers, and the pallets. The selection of the unit load, for example, the pallet sizes, the used cartons, directly affects the selection of the material handling equipment. So which material handling equipment you are going to use depends on your selection of the unit load. Okay, so that's why these designs should be made carefully. And this also, selection of the unit load also affects the physical configuration of the storage facility. So there is an interdependency between these selections. Okay, for unit load, you need to decide on the size. Okay, what should be the size of the unit load? How many items you are going to carry and store at once? For unit load containers, you need to decide on the size of these containers and the type of these containers. Okay, for pallets, if you want to select or design these pallets, you need to decide on the size, the dimensions of the pallet, the type of the pallet, wooden or material. If it is wooden, which type of configuration, and the loading method. Will you use what type of loading will be used to place these containers on top of the pallets. For storage areas, you need to decide on the types of racks. We will consider these later on in the next chapter. And the storage method, the height and the length of the storage area. You have to decide on these. And for material moving equipments, you need to select trailers, forklifts, lifts, trucks, which one of these, and there are many alternative types of these. Okay, you need to decide on these, and also for each one you need to decide on the type, size, and the capacity of the moving equipments. These pallets and containers can be expensive, and even if they are not too much expensive, even if they are cheaper, since you are using them a lot in great numbers, it makes a great cost. Okay, so what do you do with these pallets or containers when you ship the items to your, for example, customers, to your distributors? What happens to those containers? Are they attached to the items so that they are included in the selling price? Or what happens with the empty containers? So usually in the common method, what happens is when you send these items to your distributors or customers, and after usage, they send the empty containers back. But this transfer is a cost. So while you are sending the items to your customers, okay, you are paying the money for this transport. And when these empty containers should return back, again, someone need to pay the money for that. And these are all issues. How do you manage these number of containers, number of pallets? For example, as a manufacturer, if you are out of containers, what do? You go and buy new containers, or you go and ask your customers to return back empty containers. So managing these containers and pallets is a big issue. And in many companies, and in Europe and North America, instead of owning these containers and pallets, it has become a widely accepted practice to pool these. So instead of buying them, there are companies who rent the containers and pallets. Okay, so as the manufacturer or customer, you don't own these pallets or containers, but there's a third company that owns these pallets, and they are responsible for the management of these. Okay? And in this way, by using these pooling, it minimizes the movement of empty containers and pallets. It increases the utilization, so the empty pallets are not waiting idle at any space in the supply chain. There is no need to allocate extra space to store pallets because, as I said, as a manufacturer, you need to use these pallets, and you need, like the items that you are storing, the raw materials, finished goods, you need to store these pallets as well. And if you are using these extensively, then you need to have a spatial storage space for them. But if you are using pallet pooling, then when there are some excess items, you can just call the company, this third-party company, so that they can come and take excess amount of pallets. And for the maintenance of the parts, you are not responsible. Okay, the third party is responsible for the maintenance. And with newer technology, with RFID tags, it's possible to track these pallets on real time. These are the examples of managing these containers and pallets. So in the conventional method, the component supplier sends the item to the manufacturer. So these solid lines show the full load, and these dashed lines show the empty load of the containers. So there's a hierarchy here. The component supplier sends full load pallets to the manufacturer, and the manufacturer uses those raw materials and sends back the empty pallets and containers back to the component suppliers. Then the manufacturer uses its own pallets and containers to send these to the finished goods distributor, and when they are empty, the finished goods distributor should send it back. And you need to keep track of the number of pallets and containers that you sent back and forth. Okay, so this is the conventional method. In pallet pooling or container pooling, there is a third party who manages these. Again, these individual parties of the supply chain send back and forth these empty and loaded containers and pallets. But whenever there is a need, you don't buy new pallets or containers, but you just ask to the contractor so that they send you. And also, if there are some excess amount of pallets or containers, then you call them and they take it from you. So you don't store empty pallets. Okay, they are managing these pallets and containers for you. This is an integrated system in which you see here there's still a hierarchy. The component supplier is in relation with the manufacturer and the container. Again, this finished goods distributor is in relation with the manufacturer and the container. But in this integrated system, you see any party in the supply chain is in related with each other. So the finished goods distributor can send directly to the component supplier or may ask some directly from the component supplier. So these again dashed lines shows the transfer of empty containers or pallets. And if you use such an integrated approach, you see in the total cost of managing and owning the containers and pallets will be less. Okay? You will just pay a rent for these to this contractor. When we are designing the material handling system, it is not just selecting the equipment. Okay? We are not just saying, okay, this is the pallet that we are going to use, this is the container that we are going to use, this is the forklift that we are going to use. It is not just the selection. You need to think about it as a solution system, as a whole solution working system. Okay, so not just the equipment, you need to decide on the sizes, their integration with each other, their interaction with each other. Okay? The equipment selection part is one of the last steps, but in order to select the correct equipment, you need to know the alternative equipments. It's essential. If you don't know what type of alternatives are there in the market, you will not be able to select the correct alternatives. There are new equipments in the market. New equipments are continually being developed. So if you are working as a facility designer, as a material handling system designer, you need to follow the current technologies and be aware of the most current ones so that you can select the best alternative. So what are the basic material handling equipment types? How can we classify them? We will talk about this in more detail in the following lectures. Basically, we can classify them as being containers and unitizing equipments. So containers and unitizers, pallets, containers, skids that we have seen. The material transport equipment, for example, conveyors, industrial vehicles, monorails, hoists, and cranes. Storage and retrieval equipment, so it can be either unit load storage and retrieval or small load storage and retrieval. And also automatic data collection and communication equipment. So it can be automatic identification and recognition, RFID tags or barcodes, and automatic paperless communication systems. Okay, so these are the basic classification of the material handling equipments, and as I said, we will talk on these in detail, and we will see examples of these later on. Then how do we select the equipment? There are a lot of different alternatives of these equipments for transportation, for unitizing, for data collection. There are a lot of alternatives, and when you consider all possible combinations of these, there will be huge amount of alternative solutions. And how will you select the best one? Okay, so you should reduce the size of the problem. First, reduce the set of alternatives to those that are feasible. Okay, based on the material and move. So which type of move do you require? If you require a discrete type of flow, it means that you may not be able to use conveyors or hoists or bridge cranes. So you will look at AGVs or forklifts. So reduce the set of alternatives. So as I said, there generally exist numerous alternatives. So you need to be expert on this. If you are making it the first time, of course, it would be very difficult, but as you do this again and again, you can rely on your judgment and experience. Okay? Be aware that there are no single alternative solutions, single optimal solutions. One alternative usually is not superior to all other alternatives. There may be several good solutions. You should find one of them. You should find and select one of them. So instead of thinking this problem as an optimization problem, consider it as a satisfying problem. If you satisfy your needs as much as possible in the most efficient way, okay, then that's okay. You can go with that decision. Another important aspect of material handling systems design is the costs, how you can estimate the costs. And you have to design, you have to select the right method of handling, of course, with the right cost. Okay, but the thing is, the cost, estimating the material handling cost is not trivial. So there are a lot of different aspects that you need to consider. One aspect is the purchase price, the initial investment cost of the material handling equipment. And this purchase price can even vary significantly from one supplier to another. It may vary from model to model, year to year. Okay, and the thing is, there are a lot of alternatives, and it is not just the purchase price. How long will be its lifetime? What will be the maintenance cost? What will be the operating cost of these? And how can you estimate all those? Because they are usually future costs. They are not realized yet. Okay? And in order to make this decision, you need to estimate those future costs in some way. So some of the data, some of the prices in the price lists of suppliers can be outdated because they are not as grocery items. They are not sold every day, every time in large quantities. So if you make a search then you may find some older data as well. Okay, so it's important to verify the accuracy of the used information before making this estimation. What type of costs do you need to include in this estimation? You need to consider the initial investment cost. When you buy the items, if it's, for example, a conveyor or a crane, then you need to install it, so you need some installation cost. And when you start operating, if it uses gasoline, then it would have some gasoline cost. And if it is manual operated, then that manual operator is a cost for that. If it uses electricity, then the use of electricity cost is another operating cost. The maintenance cost, preventive maintenance, or if it breaks, if it fails frequently, then repairing all those included in the maintenance costs. And the operators that are going to use these equipment, the training of these operators, it's also a cost. So you need to estimate all these costs in order to make your decision, and as we said, it is not easy. While determining which material handling equipment is correct for your case, of course, cost is not the only one. You need to consider different aspects, the preference, the noise, whether it's noisy or not, the safety factor, okay, energy efficiency, modularity, flexibility, reliability, maintainability, and many other factors. You need to consider all these. Like, think about yourself if you want to buy a car, okay? So there are a lot of alternatives out there. You have some budget, and then you need to consider different aspects and make a decision. Even for cars for which we are aware of, again, it may be stressful and difficult to select. If the system is too complex that we are going to use this material handling, then maybe you may want to develop a simulation model of the system. So first, before buying all those material handling equipment, you try it with the simulation model and then finalize your decision. Safety is also another important aspect of this selection of the equipment. Occupational Safety and Health Administration has some regulations, and every country and government may have their own regulations on this. So you need to comply with these safety regulations. Most of these equipments that are sold in the market, they comply with the safety regulations. But having a safe equipment, having an equipment which comply with the safety regulations does not ensure that you have a safe production or distribution environment. So you need to design your system in such a way that the environment by itself is safe. And for this, you need to concentrate on the interface between the workforce and the equipment. So for example, if you are using an AGV, automated guided vehicle, which moves by itself, then if this AGV doesn't have some emergency stop and etc., if it doesn't have any sensors to sense the workforce or the labor or the machines around itself, then there may be accidents. Poor ergonomics account for 1/3 of all workplace injuries. So 1/3, it's a huge number, and this number is a result of only poor ergonomics. So you need to think about this while selecting and designing the material handling system. If we summarize what we covered until now for material handling systems design, we first define the material handling. Remember the definition with a lot of rights, moving the right amount of material at the right time, at the right place, with the right method, and etc. So that's the definition. We talked about the principles and objectives of material handling. We defined, or we gave you a checklist for material handling. We talked about systematic approach for designing material handling systems. We concentrated on the unit load principle, the size of the load, unit load, the unitizing equipments, and etc. We talked about the material handling equipments, how can we estimate the cost, and we talked about the safety. Okay. In the next lecture, we are going to talk about in more detail on these material handling equipments, and I will show you a lot of different examples of different types of material handling equipments.